So I want you to draw the Lewis dot structure for that. But the first thing that I want you to do is determine the number of total valence electrons for all of the atoms that are there. So what is the number of valence electrons for hydrogen?
1.
And how many hydrogens do we have?
2.
2.
2 times 1. So then that's 2. And then what about oxygen?
6.
Okay, plus 6. So we have 8 valence electrons to work with. Okay, so we need to sit there and set this up so that we can have, so that everyone can reach its octet. So the way that I normally would do this, I put the number of valence electrons around that molecule. And then, or that atom. Same thing with the hydrogen.
I can't hardly see that. I need to make it bigger.
Okay, so what is the number of electrons does hydrogen want around it?
8.
Hydrogen?
Oh, wait.
7 more.
7.
Okay, where is hydrogen located, and what is the nearest noble gas to hydrogen?
Oh,
Helium.
helium. So just
Helium.
Helium.
Okay, so hydrogen always wants just 2 electrons. It will not have more than 2 electrons. Hydrogen will never be a center atom. So in this case, since you have 2 hydrogens, who's going to be the center atom?
Oxygen.
Oxygen, yes. So the center atom is the atom that's always going to be in the center. Okay, so how many electrons is hydrogen and oxygen going to share then?
1.
1.
So each one is going to give up 1 electron to share. Okay, so we're going to draw a bond. Between hydrogen and oxygen. Okay, and over here with this hydrogen, same thing's going to happen. And so you see those 2 dots at the top and the bottom?
Mm-hmm.
These guys
Yeah.
here? So these guys are called lone pairs. So lone pairs are the electrons that aren't involved in bonding. They're called lone pairs because they're paired up, but they're not going to be involved in the bonding. Where these electrons are going to be the ones that are going to be involved in bonding. Okay? Piece of cake?
Keep going.
Okay. So let's say we have ions, right? Or in this case, these are called polyatomic ions. So I'm going to draw one. So CO3, 2 minus. Okay, so this here tells me that I need to add 2 additional electrons. So carbon has how many valence electrons?
4.
So carbon has 4 valence electrons. Each of my oxygen has how many electrons?
6.
6.
So 6 times 3 is
18.
what?
24.
18.
Oh, wait. 18.
Okay, 18 plus 4
22.
is 22 plus 2 additional electrons.
24.
So we have 24 electrons to work with here. Okay, so carbon is furthest away from being a noble gas. So typically, when you have two nonmetals that are together, the one that's going to be the furthest away from being a noble gas is going to end up being pushed in the middle. They're going to have less what we call electronegativity. So oxygen is stronger in terms of pulling the electrons. So oxygen is going to be on the outside and carbon is going to be put in the middle. Carbon can also hold 4 bonds. It could have 4 attachments. So we want to try to put carbon in the middle where oxygen can only have 2 attachments. So we're going to go ahead and put carbon in the middle. Okay, so that's 1, 2, 3, 4. Each oxygen you said had 6. 1, 2, 3, 4. Okay, and then we have 2 additional electrons to work with because that minus charge. Okay, so then if I draw a bond between here, let's take this guy, bring it down over here.
Dr. Henry, where'd you put those 2 extras? I saw you draw 1.
I put them around carbon. I always try to put them around the center atom, and then I'll maneuver them as needed.
Okay.
And then here, so if I have a single bond here,
You got
I just
6.
have them sharing these electrons,
You need 2 more.
I'm going to need 2 more because I would only have 3,
6.
sorry, I'll have 6 around carbon.
Right.
So we're going to have to borrow 2 more from down here. Good job, Lorraine, by the way. Okay, so then that gives me 2, 4, 6, 8 around carbon here. That's 2, 4, 6, 8 around this oxygen. That's 2, 4, 6, 8 around this oxygen. And that's 2, 4, 6, 8 around this oxygen. So, but we're not finished because we have to remind ourselves that it's an ion. So we want to put the brackets, and then we put the charge on the outside.
Dr. Henry, can you authorize recording right now?
Yeah, sure. Let me see how.
Mine shows it's recording.
I think you got permission last time, though.
Oh, okay.
Let's see.
Dr. Henry, is that equal next to the carbon and the oxygen?
No, that means double bond. So they're sharing 4 electrons. So the lines
Oh.
represent the sharing of electrons. Let's see.
Oh, okay.
Wait. So why are they sharing 4? Can you?
Because you
So
need
that
to
everybody
everybody around
can-
each one.
So everybody wants to have their octet. So the goal for everybody wants to get happy. Well, everybody wants to be happy. Everybody wants to have their octet, right? So carbon wants to make sure it has 8 around it. Oxygen wants to make sure that it has 8 around it. Okay? So the only way that we can accomplish that is by them sharing 4 electrons instead of just 1 set. So then that's 2, 4, 6, 8. That's 2, 4, 6, 8. That's 2, 4, 6, 8. So everybody has 8 surrounding them all.
So
Now,
these
you
two
also
lines
wanna-
represent 4 dots, and these
Yes.
out here are 4.
Yep. So you should have access to being able to record.
No, it's still saying please request, but we can save that, I guess.
Okay, hold on. Yeah, just go ahead and save it, and then I have to stop sharing real quick. And see. Actually, here we go.
Will you be uploading this Zoom meeting as well?
I will,
Okay.
now that you've asked me to. Otherwise, normally I don't upload the labs. I save them for myself,
Oh, okay.
but I will.
Thank you.
But as you guys know, it takes a little bit. Let's see. Recording. Here we go, recording.
Well, we could do that, and I'm excited that we can.
What did you ask?
Oh, I didn't know we could record on our own.
Yeah, so actually, I think you need to, on your end, if you go to settings, I think you need to set a temporary disk or a temporary place where you can store your recording,
Okay.
and you should be able to record then. So if you look next to it where it says record, do you see the record button?
Yeah.
Z?
Yes.
Okay, so click onto that, and there should be a caret right next to it. Click on that and then go down to settings, and then go to recording.
No, I don't see all that.
Yeah, so I click go to more, and then it says record on computer. There's no other options.
Okay, but you're able to record?
No,
If you click on it, it says please request permission.
Okay, how do I grant access?
But Dr. Henry, I didn't realize you were gonna upload it. As far as I'm concerned, if you're gonna upload it, that's okay for me.
But I want to give you guys the ability to record it yourself, so then that
Okay.
way you don't have to wait for me to upload it.
Okay.
Let's see.
This new computer makes me want to go buy one. It's touch screen.
Is it really?
Yes,
Alright.
it's so nice.
Okay, but then when you have touchscreen, you look like an idiot using someone else's computer because you're touching the screen.
Like this,
Yeah.
like that. I'm poking you. Just kidding.
Grant permission. Let's see. Okay, so do you guys want to try one?
Can we do the NO2 one?
NO2? Sure.
Are these the problems of the lab, or are these just examples you're going over?
So I just gave you an example. They're not the one off the lab. The
Okay.
NO2 one is kind of we're not quite there yet, but I will do the NO2 one just to kind of show you.
Okay.
Okay. So I'll figure it out, and then, but I'll put the recording up, and I'll try to get an answer for you next time. There. Oops.
Which one did you want to do?
NO2. Okay, so
NO2. I don't see NO2. Oh, this is just picking it out of there. I got you.
no, it's the third one, NO2. You
The
don't
third
see
one
it?
on here says AS.
No, go down.
Down further. Oh, there we go. Thank you.
Okay, so I have NO2. So how many electrons does nitrogen have?
5.
How many does each of the oxygen have?
6.
6.
So we have 2 oxygens.
12.
So altogether we have 12. So that's 17. Now, anytime that you end up with an odd number that means that you're not going to end up with a total of the octet rule. You're not going to be able to complete the octet rule. So anytime that you see this and your number is like 17, right, or 15, or any odd number, you're never going to be able to meet the octet rule. So the rule is, in that case, the guy who is the strongest, who's the closest to being a noble gas, is going to make sure that it gets its octet first. So who's going to be the center atom? Oxygen or nitrogen?
Oxygen already has 8,
No, I have,
Oxygen does not have 8.
according to this.
According to what?
Oh, never mind. 1, 2, 3, 4, 5. It has 5.
Okay, so what did I just say earlier about the rule? Who goes in the center?
oxygen is closer.
So oxygen is closer to being the noble gas. So who goes in the center then?
Nitrogen?
Nitrogen. So
Dr.
remember, the
Henry?
one that's going to be the weakest gets pushed in the middle. Kind of like, okay, so you guys have siblings. Any of you guys have siblings?
Yep.
Did you guys used to ride in the car together?
Yeah.
Who
Yeah.
got put in the middle? Is it the strongest or the strongest sibling, or is it the weakest sibling?
The youngest always rides on the floor.
Okay,
On the floor.
I'm from old school. I'm 57 years old. That's before seatbelts were required.
okay. So in other words, the youngest got put in the middle, right? So are they
Yes.
typically the weakest?
Yeah.
Yes.
Okay, so the weakest always gets put in the middle, right? Just like in real life, the person who always end up having to sit, as we used to call it, bitch, would be the person that was the weakest. They would have to sit in the middle, okay? Excuse me, no offense to anybody, but that's
None
what we,
taken.
as a kid. So in this case, nitrogen is going to be put in the middle. How many electrons does nitrogen have again? Valence electrons? 5.
5.
1, 2, 3, 4, 5. Okay? So also, since nitrogen is the weakest, it's going to get screwed in terms of being short electron. Oxygen is going to make sure that it gets its own, right? So oxygen has how many electrons? We said valence electrons.
6.
It has
6.
6 valence electrons. This guy has 6 valence electrons. Okay, so, but nitrogen is going to try to get as close as it can to reaching its octet, right? So here, we're going to share these electrons. They're going to come over. And so you're going to have one side. It's going to be a single bond. Double bond. And one on top. Okay, so how many electrons does oxygen have around it?
8.
That's 2,
4
4,
or 6.
6,
6.
8, right?
Plus the 2 from the end.
And then you have
4.
on this side, you have 4 that it's sharing, and then you have 6, 8. So it reaches its octet. But look at nitrogen. How many does it have around it?
4, 5, 6.
Keep counting, because that's each
7.
one is 2. So that's 2, 4, 6,
6,
7.
8,
Okay?
7. So it
that's
needs
the best
1.
that you can do. So this is an exception to the octet rule.
Okay.
So anytime that you end up where the total number of valence electrons is an odd number, you know that you're going to have an exception.
Okay, and now so like for the HNO3, that one is 3 of them. So how do you know which one goes in the middle?
Okay, so you tell me. what did we say? Who's going to go in the middle in this case? HNO3.
Probably nitrogen.
Okay, that is correct. So why doesn't hydrogen go in the middle?
There's only one away.
Because it's also only one away, right? And it can only make one bond. It can only have a single bond. It can have more than one attachment. Okay. And we know that oxygen is stronger, so it's going to all push nitrogen in the middle in that case. Okay. Questions, concerns? Oh, did everybody get that before I erased it?
Dr. Henry, where do you got the number 17 for that part?
Okay, because we have each valence electron that oxygen have. There's 2 oxygens. Each one has 6. 6 times 2 is 12, right?
Yeah,
Okay, nitrogen has how many valence electrons?
5.
So 5 plus 12.
It's 17. Okay. Yeah. Okay.
Okay, so if you count, at the end of the day, you need to use all 17 of those electrons. So that's 2, 4, 6, 8, 10, 12, 14, 16, and then that's your 17th. Am I making you lose your hair, Z?
No, I lost it before the class.
Okay. I'm like, man, bruh,
Thank you.
within the first
Dr.
week.
Henry, so the sum that we used for the electrons, it indicates how much we're supposed to use in total.
Yeah. So this here,
Okay.
this tells me the maximum amount of electrons that I can use. Because there's a tendency, especially as a student, you start just throwing things in there just to try to make it work. And then you'll end up with like 50 extra electrons, right? But you can't because you only have 17 to work with. So you want to use what you have to work with.
Okay.
Okay? So do you guys want to try a couple
I have
more?
a quick question.
Yep. Go
I
ahead.
have a quick question for are we gonna do it in paper and then submit it in a document, or do we have the option to do it in on one device?
So you have the option of submitting it into your class notebook, right? So you can take pictures of, okay, so your Lewis dot structures you got to do on paper, right? And then you can upload it to one notebook, or you could do it in one notebook as well. You can draw it in one notebook.
Yeah, because you mentioned previously for the labs we needed to use one device, but I just wanted to make sure if in case I do it by paper, I could just take a picture and just.
Yes,
Okay.
you can upload it there as well too, yes. But you're gonna put it into your notebook.
Thank you.
There, okay?
Okay.
Okay, any other questions?
Were we doing a report on this as well, or?
Yes, you're gonna be doing a report on this as well.
Okay.
I don't know how.
So there are instructions in class notebook?
I was joking.
Okay, you're just giving me grief, huh?
Yes, sir.
I feel the pain. Okay, so down here, you're also gonna be drawing the Lewis dot structures for each of these elements as well.
Mm-hmm.
Okay, questions?
Are you gonna be here to get help if we need it?
Yep. I'm gonna be here, but I actually am gonna take a quick break to go grab something to eat because I'm starving. And I'm a lot nicer if I have food in me than if I don't.
Okay.
Yep. So, but while I'm gone, you guys could actually help each other, right?
Yeah.
Yep. Okay. So, and you guys, I'm just gonna keep you here. If you have questions, you don't have to stay. I just wanted to introduce you to the lab so you guys have it available to start doing. And it's not due this week, it'll be due next week. Not this Friday, but next Friday.
Okay.
Okay?
So our only homework for right now is the lab and the discussion.
That's correct.
Okay.
Okay?
Okay. Thanks, Dr. Henry.
You're welcome.
I just want to say thank you for us computer illiterate people. You always help us out good. I appreciate that.
No problem. I know
Anybody over 35 has problems with computers.
Nah, actually, I've had more people that were like 18, 19 that have emailed me about issues with computers. They've been more so worse off than some of you guys are. And then also with using certain, because a lot of them don't know how to use Word because they use Google Docs. And so they have trouble with that, or they don't know how to use Adobe Acrobat.
Yeah,
Right.
it's a matter of learning the computer programs. You know what I mean?
Yeah, yeah.
And I didn't take the opportunity to learn that, and I probably should have.
Yeah.
Because it'll help me out a lot in the nursing program.
Yep. Yeah. And you got to be flexible. You got to be adaptable and make quick modifications. You can't get so bogged down, you know. So, and that's what we.
So we're doing the Lewis diagram on ICI, SI, H4, PH3, and right?
That's right. So for right
Okay.
now, all I want you guys to do is do the Lewis diagrams. So
Essentially, the
this
way
is
you
gonna
just
set us
showed us.
up for molecular geometry. And so
Okay.
first we need to get the Lewis diagrams down pretty well. Then molecular geometry is going to be a piece of cake.
Okay.
Okay. Now don't look
So
so bored, Z.
I'm sorry, I've just been working a lot of doubles. I'm not bored.
Okay.
I don't work doubles. I only work one.
Okay.
And
Okay,
then I
so
call in sick.
I'm going to run and grab some food, and I'll be right back. Okay. So you guys help each other for right now. Let me see.
Yeah, if they give me the answers.
They're not going to give you the answers. You got to earn those things, you know?
Okay. I'll figure it out.
Can you grab me one of my colored pens, please? What?
Okay, thanks, Dr. Henry.
You're welcome.
I'm going to go get ready for work. I'll have this done by next Friday.
Sounds good.
Hey, are you guys still there?
Yeah.
Yep.
Are we going to work this out together, or what do you want to do?
Actually, I was wondering the same thing. Is there any kind of like a phone list or anything? Do you guys keep in contact outside of class hours, or is it just?
No, but I will give mine.
Yeah, that might not be a bad idea. Maybe for those of us who can't stay or don't get it, maybe we can check in with each other too.
And then we have to work and stuff. Like you said, lots of doubles.
Yeah. So I'm actually getting ready to leave the group. So
Yeah, me
I don't know,
too.
maybe we can make some kind of way to stay in contact. But
Okay, we'll write a pencil down. Ready?
go ahead, I'm ready.
981
Uh-huh.
6376. Lorraine Garner. And you can reach me on Unit 4 at 3625.
Well, I would be able to get a hold of you for sure, but I'm just saying, just as a resource for everybody.
Right.
Yeah.
I like that idea. We all
Um,
could help each other. It'd be a lot easier for us all.
Okay, has anyone done the N or HNO3 one? Because the H doesn't go with the N, and I don't understand why.
Yeah, we did. That was the last one we did.
Oh, we didn't do that one.
Yeah, I'm working on it right now. I'll let you know when I'm done.
Really? I thought we did it.
No, we did not.
Shame on me. No, we didn't do it. You're right. Hydrogen, nitrogen, and oxygen. I keep leaving my freaking periodic table at work inside of my envelope in my office. I need to remember to keep that with me like my badge. Does anyone know what BSER EPR theory is?
Volume by chance on your screen?
Do you have what? You volume?
Like a mic volume? Because it sounds on my end like you're screaming.
Oh, I'm sorry. I'm very loud. I didn't mean to be loud.
No,
Is
I
that
just
better?
wasn't sure if it was just your mic.
No, is that better?
Yeah.
Okay, my apologies. I get excited and I get loud. I came from a very large family. And I was kind of in the middle towards the end.
Mm,
And nobody ever listened to me, so I had to yell.
makes sense.
Yeah, my kids have bad hearing now.
Don't be nosy. Play your game.
Okay, so am I under the impression we're supposed to do 1 through 5 and then do the other ones? ICI, SIH4,
Yeah, do
PH3?
all of 1 and all of 2.
There's another one below that too. C104, HF, H2O, NF3. There's all kinds of these things here. What does he got going here?
I would just do the first 2 to start.
I think he wants all of them done. Okay, I'll start with the first 2.
I want you to get started. That's what I want you to do, so you know how to do it.
I figured you'd be out there listening.
Mom, I'm already doing good.
Great.
See?
Mia, I'm in
Look
class right now.
I got a charged shotgun gold, and I also got the awesome rifle.
Lovely. My screen just shrinked. Oops, I'm sorry, I'm writing on your screen. I can't.
Is that how you guys set it up? HNO?
Here,
No.
I'm gonna draw it on like paper real quick and then I'll hold it up.
Why can I not? I think I
Because
broke
which one was supposed to go in the middle? N, right?
There we go. So I wrote it like this, where it's N is in the middle, and then an O right here, an O right here, and an O right here. Wait, just kidding. That was over here. I don't know if it actually matters, but. And then this is bonded with the H. And then these all get 1. And then you just add the 6 around them all. That's how I have it, but I don't understand why the H is over there and not under the N or something. But that doesn't. So one of those O's should be double bonded because of the 5.
So the H can't be connected to the N at all?
It's not when I Google it, so I'm gonna assume. Whitney, we can't hear you. You're muted, but you're talking.
Lovely, thank you. The reason I didn't double bond the oxygen is because like the nitrogen can only fill up to 8, right? Yeah. 5. And so it can only connect to like oxygen those 3 times.
Well, hold on. Because you need them all to get to 8. The oxygens have to get to 8.
Yeah.
You have 6. So if you take 2 nitrogens and give it to the oxygen to share, that makes 8. So you would do that with 2 of them, right? And then not very good at explaining this.
No, it's okay. It's annoying. It's hard. All right. Yeah. And it's new, so that's even better.
You need 24 total.
Right.
So the H is definitely going to take one of the oxygens away from one of the oxygens.
Does it matter what side the H is on?
I don't think so.
I don't think so.
So yeah, so that oxygen with the H though is only gonna have one bond to the nitrogen because that gives that oxygen 8 total.
Okay. Oh, I see. So the O, so one oxygen double bonds to nitrogen. The other oxygen single bonds to nitrogen. There's a single bond to hydrogen, and then 2, 4, 6, 8. I'm missing an oxygen. This makes no sense. This is weird. Maybe when he comes back, he'll help us like do an example, or just like have this be an example or something.
Yeah. I hate in his class where I like zone out for a second and then I don't know what's going on. Because I feel like it goes so fast.
Okay. So where it says, okay, so this one, you can only do the first part right now because we haven't got to determining what the center atom is or polarity. So all you need to do is worry about drawing the Lewis dot structure first, and that's it.
No,
Then,
number 5 on number 2.
oh, number 5 on number 2. Oh, okay. See, you guys are getting,
Sorry.
okay. Okay, so can I clear my screen?
Yeah.
Yes.
Okay, so who's going to be the center atom?
Nitrogen.
Nitrogen.
Okay, nitrogen. How many? Let's go ahead and put nitrogen. How many valence electrons does nitrogen have?
5.
1, 2, 3, 4, and 5. Okay. How many? Let's see. And we have how many oxygens?
3.
And they have how many valence electrons?
6.
I have a question really quick. Do we just fill in the dots like however, or are we going like clockwise or something, or how does that work?
I just do it however, what looks more
Okay.
convenient.
Okay.
Because the thing is that the electrons are mobile, right? So they're moving around anyway.
Okay.
Okay. Okay. So, and we also have a hydrogen, right?
Yeah.
Okay, so is there any way that we can make this work? How many total electrons do we have?
24.
24.
So we have 24. Okay, so if we have a bond between the hydrogen and the nitrogen, that would be one bond. So if I have a double bond here, I guess that won't work, right? We're kind of screwed, huh? So what about, we don't do that, we do this. The hydrogen over here, so 6, let's do this. That's 1. So, okay, so we have 3 oxygens, so that's a total of 18. Is that correct? 6 times 3. Nitrogen has 5, and hydrogen has 1, right? So that's a total of how many electrons?
24.
Okay, so that's 2, 4, 6, 8. We need a double bond somewhere. Two, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we count it for all the electrons. Does this guy have 8 around it?
Because it's bonded, yes. But what about the nitrogen? I mean, it used to have 5 and now it has 4. Well, I mean, it has 8, but I don't know what happened to that 5th.
Because oxygen, it's sharing 1 electron with the oxygen, that's sharing 1 electron with the hydrogen, right? So we have 1, 2, 3, 4, 5, 6 around oxygen. Hydrogen has 1, so you have the one that's sharing here, and so the other one is sharing here with that 1 free electron. You see that? No? So let's do it like this.
The nitrogen?
What was that?
The hydrogen somehow balances the nitrogen?
Yeah, because it's offering 1 electron, but instead of, because your first instinct is to put the hydrogen here, right? But regardless if you put the hydrogen there, that's going to give you too many bonds, right? And you would need 5 bonds to make it balance out, right? Because then either one of the oxygens are going to be shorted or something along those lines, and it's not going to work out. It doesn't obey the octet rule. Okay, so what this tells us is,
sorry.
So let me.
Yeah, sorry.
Go ahead.
Okay. I had. Click on mute. Okay, I had this this is my answer, but it just didn't look right. But this is what I mean. Like this one electron up here. Like, what's that guy do?
Wife, she was gonna get him lunch.
It's going to move.
Okay.
It's going to share with the oxygen, right? So
Surgical PE.
Because how many electrons is oxygen sharing with hydrogen? I mean, oxygen sharing, yeah. Oxygen sharing with hydrogen.
I was wrong.
One.
One.
Sorry,
So that's
is someone
one
watching
electron,
TV?
right? What was that?
Is someone watching TV? I can't hear you.
Oh, my apologies.
Thank you. Sorry.
So that's one electron that's being shared right there. That's 2, 3, 4, 5, 6. So those are the 6 electrons. That's that one lone electron right here that they're sharing from nitrogen. Then that's 2, 3, 4, and then nitrogen offers another one to share here, right?
That's the part I get lost on. Like, how does it just throw 3 at oxygen?
Because electrons are mobile, right?
Yeah.
So long as they're reaching their octet, nitrogen is willing to give up as many as it needs to reach its octet. So here, this one is the actual, because if you think about it, oxygen has 2, right? I mean, oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. Actually here, it throws in 2 electrons. Nitrogen throws in its 2 electrons to share.
Oh, okay. But is there a way to show that? Like, I know it can't, is it double bonded? It's not, so. I don't
Nope,
know.
it's single bonded
Right.
because the electrons, they're nitrogen's electrons, but nitrogen is being kind of bullied in a sense to share its electrons because oxygen has a stronger pull. And ultimately, nitrogen is like, okay, I'm cool with it long as I get to my octet as well too, which means that I'll be at a lower energy level.
Okay.
And then here, this oxygen throws into, and then nitrogen throws into, right? So they're both throwing in 2 in that case.
So it's throwing 2 to that left oxygen, 2 to the lower oxygen, and then 1 to the right because the hydrogen.
Exactly. Yep, and
Okay.
that's the total 5.
Is there, so I did look up an example after I was thinking about it, and on some of the examples online, they have like positive sign, like I think negative is a +1, or nitrogen is a +1 charge since it got rid of that extra electron.
So that deals with bond order, right?
Okay.
So let me show you the way that you do this, right? But for your first, you guys don't have to worry about bond order. In this case, nitrogen would have a 0 charge on it. And the goal is to try to keep a neutral charge on everything. You want everything to end up with a 0 charge ultimately.
Right.
So the way it works is, okay, so if you take the lone pair, the number of lone pair electrons, so this is the way it's done. So you have your number of valence electrons minus your lone pair electrons. So there's a total of 4 lone pair electrons minus the number of electrons that are the number of bonds that are being formed. So in this case, there's 2 bonds that are being formed, since it's a double bond. So you want to try to get this so it has a 0 charge. That would be the best. If you can't get a 0 charge, you want the lowest number possible. So this guy around here would be a 0 charge. This guy, so how many valence electrons does nitrogen have normally?
5.
How many bonds do we have here?
4.
5. So then this guy would be a +1 on the nitrogen. Okay, now around here, oh, let's do this one here. So this oxygen here is, how many valence electrons does it have normally?
6.
How many lone pairs electrons do you have?
3 pairs.
So that's a total of how many lone electrons?
6.
And then how many bonds?
1.
So this guy would give you a negative
1.
1. And then this guy here is how many electrons does valence electrons does oxygen have normally?
6. And then minus 4. And then those minus those 2 bonds.
Okay.
So it'd be neutral.
And then hydrogen is just that 1, so you're good to go. That's always going to end up being 0.
Okay, I think that's the part that was just confusing. So do you want us to write the charges?
No, you don't have to worry about writing the charges. At the level that you guys are at, I'm not concerned about it. But if you're in my 1A class, you're going to learn to do that.
Okay.
Because that tells you how correct your structure is. So
Gotcha.
this lets me know that this Lewis dot structure is a pretty good structure because we have a really low number. We have like 1, right? So it's 1 and minus 1. And at the end of the day, if you add these all up together, they should equal 0. If the molecule that you're looking at or the compound that you're looking at has a neutral charge. So that it should add up to the same charge that this compound is at.
It kind of helps keep track of like where that electron is going. Can I write it and it would be fine?
Yeah, that'll be fine. I won't hold it against you if you write it.
Okay.
So I'm doing one further down. It's ClO4 minus 1. I have it written out, but I'm only coming out with 32 electrons.
Okay, so let's take a look at it. Can I clear this? Everybody got this down?
Yeah, good. Thank you.
Someone needs to change their fire thing.
Okay, so you said ClO4 negative.
Yeah, -1, yeah.
Okay. So this one is going to be a little challenging, but it'll be good. I like it. So who's going to be in the middle?
Yeah.
Nope. Who's closest to being?
Oxygen.
Oh.
So oxygen is actually going to be in the middle.
There's 4 of them.
Yep. And only one of them get to be in the middle. Okay, so we have 1, 2, 3, 4, 5, 6. This minus means that I'm going to add 1 additional electron to it. And usually you throw it in the center because it'll get accounted for. So if this is a free electron here, so this one is it's a doozy, everyone. So this is a free electron that we have to work with, right?
Okay.
So if we have another oxygen, it has how many around it?
6.
Okay, so that's 2 oxygens that we have accounted for. So if I put my Cl here, it has how many around it?
7.
Lunch.
Okay, so we got the formation of a first bond here. Oops. So this guy would give us our second bond. Oops. Okay. And then we have 1, 2, 3.
So that oxygen, the next one would go right on top of the other oxygen, right?
Yep. So 1, 2, 3, 4.
Is that going to be a double bond?
Sorry, hold on. Let me move this real quick. All screwed up. And then the last oxygen is going to go where?
Underneath the bottom.
Okay. So then this bond is going to be double or single?
Double.
Are you sure?
No.
Single for now.
Single for now. And then this one is going to be single. So now we just need to count to make sure that everybody's octet is filled. So we got 2, 4, 6, 8 around this first oxygen. We'll put a 1 here. We have 2, 4, 6, 8 around our second oxygen. We have 2, 4, 6, 8 around our third oxygen. And then we have 2, 4, 6, 8 around our fourth oxygen.
No doubles.
So no doubles, all singles. And then we want to do this. Put bracket. Sorry. I have to fix my bracket.
But it's still only 32. Where'd that one random one go?
In the middle. Right? So let's count them all up, right? So you have 7 from chlorine plus the 1 that we're adding on plus 6 times 4.
24.
So then that should be what?
32.
Oh, I did my math, man.
Piece of cake?
Yep. So with HF, what goes in the middle since they're both 1 away?
Say that again.
The next one is F. Which one goes in the middle because they're both 1 away?
F and Cl?
Wait, there wouldn't be a middle. Just kidding.
Okay. Whew. And remember, the one that typically can hold more bonds or the furthest away from being a noble gas is the one that has to go in the middle. Right? Typically.
So can you explain Vesper?
Yes. So VESPER actually stands for valence shell electron valence shell electron pair repulsion theory. So that basically means that pairs of electrons, so if you have two pairs, these guys here, these are your lone pairs. So they're going to try to be as far apart as possible. And so that's going to help us with the geometry. Okay? Because, you know, it's like, you know how you get guys that go to the movie theater together, right? They're friends, they're not dating each other, but they go to the movie theater together. There's 6 chairs, there's 3 guys. 6 chairs, are they going to sit right next to each other, or are they going to sit with spacing in between them?
Space.
Okay? So because they want that room, just in case a hot girl comes by and they could have a seat for them, right? So that's VESPER, essentially. You want to make sure that you have room to stretch and do all what you need to do.
Okay.
Okay?
So we don't have to central
What was
add
that?
the central add. We only have to draw the diagram for now.
Yep.
Will we have to do the rest later?
You will have to do the rest later, yes. But we haven't gone over it, so it won't be any benefit to you until we go over it.
Okay.
You know what I'm saying? I could try to beat it in your head right now, but it's not going to do you any good until you start getting the other stuff that goes with it. So,
Okay.
but I wanted you to get the Lewis dot structure because it's amazing. It's not too hard, but it just takes practice to kind of get it and start seeing it. You know, once you start getting the hang of it, it'll just fall into place. And that's what I want things to happen for you guys. I want it to fall into place because it makes the course so much easier for me and makes the course so much easier, and it'll be funner later on when you're actually starting to do the hands-on stuff. So start clicking a little bit better. Okay. So are you guys good?
Yep.
Great, great. Okay. Anything else that you guys want to go over?
Can we go over number 2 and number 2?
2 and number 2. That's a good one. Okay, so sulfur and oxygen are in the same group, right?
Yes.
And so they're both 2 away from being a noble gas. So the way that you decide who's going to go in the middle is going to be based upon who's higher on the totem pole, right? Or who's higher on the periodic table. Since oxygen, it has a smaller shell overall, it's going to have a stronger pull because the electrons are closer to its shell than sulfur. So then, in that case, sulfur is going to get forced in the middle. Okay? So, if that's the case, what are you going to do?
Draw them out.
Okay, so who's going to be, I know you're going to draw them out, but who's going to be in the middle, smart ass? Gosh.
I wasn't trying to be a smart ass. Well, sulfur's gonna be in the middle.
Okay,
right?
so let's put sulfur in the middle. How many valence electrons does sulfur have?
6.
Okay, so it also tells us that we have 2 additional electrons. So let's not forget those. So we're going to just add those up top here. So those are my -2 electrons. Okay, so then we have 4 oxygens. And each oxygen has how many valence electrons?
6.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay?
So in
And
total, it should be 32.
1, 2, 3, 4, 5. So, yeah. So, in total, we'll have 32 electrons. That's correct. So, do we have 32 electrons?
Yes.
Okay. So,
It's basically
how many bonds are going to be here?
just the one.
Just that one.
It's one all around, right?
Yep.
And it would need to go in the brackets.
Yep, you're going to have to put it in brackets. Good job. It's so funny because when I was at your level, I would always forget the brackets. And my instructor was, it's either right or it's wrong. There's no in between, so he wouldn't give partial points. He would just like,
0.
Yep.
And that would be it, right?
that would be it. Good job.
Cool. Thank you.
Yeah. So pretty simple, right?
Yeah, now that we did more examples, I feel like, yeah, it is simpler.
Yeah. But don't worry about it. On the exam, you're going to have to draw the Lewis dot structure of one that's going to be like 10 molecules or 10 atoms or something like that. So it'll be fun.